Hello, welcome to my Algebra 1 review series. This video covers Chapter 9, Section 6, titled Factoring Trinomials of type ax squared plus bx plus c. By the end of this video, you'll have reviewed past lessons describing the methods of factoring trinomials of type ax squared plus bx plus c. In the process, you will review factoring types ax squared plus bx plus c when c is positive and when c is negative. That's ax squared plus bx minus c. You'll be looking at factoring out a monomial first to complete the review. If you'd like me to cover more of these topics in greater detail, please leave a request in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you. Objective 1. Factoring ax squared plus bx plus c. To understand how to factor ax squared plus bx plus c, where a is positive, a positive integer, greater than 1, consider the following product simplified using FOIL. Okay, so we have the two binomials, x squared, 2x, excuse me, where's my pencil? Right there. 2x plus 3 and 5x plus 4. They're all being multiplied. And when we multiply these together using FOIL, we get, as you know, 2 times 5 is 10, x squared, 10x squared. We get the outer, which is 2x times 4 is 8x, and then the inner, 3 times 5 is 15x, and then the last, 3 times 4 is 12, which gives us 10x squared plus 23x plus 12. Okay, so then to go from ax squared, bx plus c to its factors, you look for binomials that have the following characteristics. So we're looking here at the product, where it says the product is A, and product is B, C over here, right? And then on the bottom it says the sum of the products is B. So you have your A term right here, you have your C term over here, and your B term is whatever the centerpiece ends up being when you sum these two together using, after we've gone through FOIL to create these. It's like up here, the 8x and the 15x. These are those two inner terms that we're talking about. And what we're going to end up doing is where it says product is A, we're going to take A. If A is 8, let's say A is 8. We're going to break it into its factors. 8 times 1, 2 times 4. Okay, those are the factors of 8. And of C, if it was, say, a 12, it might be a 1 times 12, 3 times 4, or 2 times 6. Those are the factors of 12. And we're going to be writing them down. You're going to see it. We're going to write each of those down in a pattern, in a table, so to speak. And what we're going to be looking for is the sums of those, the sum of the product of those. So if you multiply the two together and then add them, you're going to get a product, a sum of products. And that's the B term. And we're looking for the B term to be the same as the term we're looking for, like say in the 23x. We're looking for it to end up being equal to 23. And we'll see it as it comes along. So also, if C is positive and B is positive, the two factors of C are positive. We learned this in the past, in the last section. If C is positive and B is negative, the two factors of C are negative. Okay, we're going to move on. Okay, example 1. We're going to factor 6n squared plus 23n plus 7 when C is positive. That's what we're looking at here, when C is positive. So here's what we do. There's a pattern to this. And I end up using a table. I kind of format the same table over and over and over again. And if you do that, you really probably won't get screwed up, so to speak. And I try to, it's a system. You just do step A, step B, step C, step D, right? That's how I view these problems. So what we're going to do is I write out the problem in the squared term, then the sum terms, right? And then the last term. You have these. Okay, we have the F, O, I, and L. Find it to be helpful. This is your first and your last. So this is the 6 for the first, right? The 6 is the coefficient of the first term, and the 7 is the number we're going to use in the last term. Okay, in the inner ones, we have O and I, FOIL, right? So let's bear with me. I've got parentheses. You see I have this is a product here, 1 times 6, which happens to be the factors of 6, 1 and 6. And there's also another set of factors in 6, which is 2 times 3. So that you see there's 1 times 6, and then there's a space here because there's a row here. I'll show you what happens with that one. And then, so for every set of factors, you get 2 lines. So this factor has 2 lines, and then these factors have 2 lines. When you go to the other side, the last, so this is just a layout problem. All we're doing is laying it out. So now we have 7 and 1 are the only factors for 7. So we have the 7, 1 and 7 is one set of factors. And now when we go to the next line, we switch them from 1 to 7 to 1. And then you go 1 to 7, 7 to 1. Okay? And these switched on this side for every one of these on the other side that don't switch. So I've got 1 and 6, 1 and 6, 2 and 3, 2 and 3. So these always stay in the same order. The ones on the right hand side, you switch them. Every other one, you switch them. Okay? So now, what do you do with them? Here's what I like to do. The book does them, they have it laid out in a way here that I don't normally do it, but on this one, since it's their problem laid out in the book, I'm following their system. But and it looks like, and this is how I would do the same thing. On the first term, the 6 of the 6n squared, you take the factors 1 and 6. You take and put the 1 factor here and the 6 on this side. So you see the outer on the parentheses on this side and the outer of the right side of the parentheses on that side. And I keep it the same. So it's right here and over here. So I've got the 1 on the left, on the far left, and the 6 on the far right. If you go down one more on my next set, 2s and 3s, I have the 2 on the far left outside and the 3 on the far right outside of these parentheses. Okay, so this is just still layout. If you practice this, it'll become easy. So, and they don't change. It's 2 and 3, 2 and 3, 1 and 6, 1 and 6. They don't change. Now, what does change is when you go from one line to the next. So I have the 1 and the 6, and you take the first set of factors over here, and you put it inside your parentheses. You fill in the other hole. So in this case, they have it backwards. I would do it. I'd put the 1 over here and the 7 over here. That way I always go from left to right. But they don't do it. And when we do the work problems, I will do it that way. So the first one is a 7 and a 1. And then on the next row, you switch them. You put the 1 here, 7 in the right here, and the 1 right there. Now you go to the second row, and it's the 1 first, and then the 7. And then you go to the next row. Now we've switched to the 2s and 3s on the side over here with the F, and we go back to a 7 and 1, and 1 and 7. So you just fill in these and don't move them around, and you flip-flop the last. See, I think you can see the pattern. And now that you've done that, now you take, and you've got them laid out, you go through here and you look, you're going to multiply these. It's 1 times 7 plus 1 times 6. And I have an equal sign here. So what is 1 times 7 plus 1 times 6? It's 13. Is 13 what we're looking for? No, we're looking for 23. Let's go to the next. 1 times 1 plus 7 times 6 is 43. 7 times 6 is 42, plus 1 is 43. And is 43 correct? No. How about 2 times 7, which is 14, plus 1 times 3 is 3. 14 plus 3 is 17. Is that a 23? No. Let's go to the last one. 2 times 1 is 2. 7 times 3 is 21. 21 plus 2 is 23. And as you see, voila, we've got the 23 right here. So we found it. These are the factors now. We found the factors that we're going to use down here. So how do we lay them out? In the O, F-O-I-L, under the O, you find the 2 and the 1. Well, you take the 2 and you put it in the first location, then outer, inner, last. Put it in that first, and then put the 1 in the last position, way down here. And then you go here to the next set. Now in the inner, you put the 7 down here on the inner ones and the 3 on the other inner. So you see you've got the 2 in the beginning and the 1 at the very end and the 7 and the 3. Those are your terms. Those are the factors for this 6n squared 23n plus 7. You can check it. You can go back and say 2n times 3n is 6n squared. 2n times 1 is 2n. 7 times 3n is 21. 21 plus 2 is 23. And 7 times 1 is 7. Okay, we're going to do some problems, and hopefully by then you'll see it. It'll kind of start making sense. After you do a few of them, you'll start seeing the pattern. There's nothing hard about the mathematics. It's just a pattern. Okay, example 1 under the check your understanding. If you'd like to stop the video and go off and do these on your own, you should. There's 3 problems coming in order here. But I'm going to just continue working on them. After you come back, we'll do them together. But give it a shot if you'd like. Okay, now we're back. We're going to go ahead with this. So the first thing we have here is to factor each expression. It says, well, there are 3 of them in a row. The first problem is 2y squared plus 5y plus 2. So I've broken it out. As you see, I've got the first term, the middle term, and then the last term. The 2y squared, the 5y, and the 2. We've written FOIL, and it'll kind of help organize this for you. And like I was saying in the previous slide, that keeping this organized is going to be helpful tremendously. And always do things in the same order. If you could learn the order that you like, that you're comfortable with, I'm going to use the one I'm comfortable with. You use the one you learn an order and practice it. And then when you get to the test, you just lay down your pattern, like this pattern here. Once you see this pattern, you know exactly what to do. Lay it out, your parenthesis, do all the parentheses, the plus sign, the equal sign. Get used to drawing that pattern out and how to fill it in. And the answer comes up for you almost automatically. So the beauty of this. So now we're going to take the factors of the first term. We're going to find the factors of the first term and the factors of the last term. They're both 2's in this case. And I'd also like to remind you of one thing. We are in the section where it says factoring ax squared plus bx plus c, where c is a positive number. And when c is a positive number, that means your factors can have 2 things. They can either be both positive or they can both be negative. Okay? And how do you know which one you want? Well, we've talked about this in the past also. The middle term, if the middle term is positive, you want the positive factors. If the middle term is negative, you want the negative factors. And it's just that simple. In our case, it's a positive y, so our factors are going to be of 2 are going to be 2 and 1, and they're both going to be positive. Okay, so let's run it out. Let's do it. So the first thing we're going to do is we're going to factor out, and also I have more patterns of parentheses here than probably necessary. I just did them out on the slides and then just copied them so that I'd have them all ready for me. I didn't have to do it, but we may not use them all. So don't expect that we're going to use always, in this case, 4 rows of parentheses and equal signs as I've got laid out here. But let's start. So the first thing we're going to do is, and I always start with the lowest factor first when I do it. And that's only me. It's nothing, it just helps keep it organized in my head. That way I know what I've done and where I'm going and where I've come from. So the factors of 2, and so on the first side, we only lay down the factor 1 time. In this case, it's going to be a 1 times a 2. That's what we have here. I could do 1 times 2 here again, but I don't have to. Okay, I can just leave this like that because it's the same term. And then what else do? I told you last time, I take the first term and put it way over here on the left, and the last term, the second term, the 2, put it way over here on the right. Okay? And based on the first term, you do it as many factors as you need. Well, we need a 1 and a 2 again. Okay, and that's so far. So now we're going to go to the left side, or the right side, with the L term. Again, it's a 2. So it's going to be a 1 times 2. exactly the same as the first. And since we said that they're going to be positive, we don't have to worry about negatives in here. And then this time, though, on this side on the right, we flip them. So we're going to do a 2 times 1. And that's the reason why we have two columns over 2 over here. We have to have 2 matching over here because you have to get all the combinations. And once we have this now, we can go ahead and fill in the rest of the missing spaces here. So we filled out the F term, the 1 and the 2. So now we have 2 of the inners, right? We did the outers, and now we're going to do the inners. And the inners are, keeping them in order, a 1 right here and a 2 right there. Now you go down to the next line, and it's a 2 and a 1. So what do we put in here? We put in, and we really don't have to put anything in. We're going to put them in down here. However, we need to put dots in here because we have to multiply them. So 1 times 1 plus 2 times 2 is how much? 5. 1 times 2 plus 1 times 2 is 4. Well, we could have stopped when? On the very first time. Why? Because we're looking for a positive 5. That was our solution. So that means that this row here across this whole thing is our answer. And how do we get our answer for our factoring? We go up here to the top and we take the outer. The O is important here because it's outer. So this group here is going to give us our outer values. So the 1 goes here to the outer, and this one goes here to the outer. Okay? And now you go to the next set. This is the inner right here. Inner right here. Inner. Should I change the color on it? This is the inner set here. So this is 2 and 2. So we're going to put a 2 here and a 2 here. Now we've got the thing solved because it's y. So it's 1y plus and a 2y. And these are both pluses. That's it. We're done. If you want to do it, you want to check yourself. Y times 2y is 2y squared. 1y times 1 is 1y. And then, so we have that. Now the inner, we have 2 times 2y is 4y. So we have a 1y and a 4y, gives us 5y. And then a 2 times a 1 gives us the 2. Okay, I could write it out, but I don't think we need to. So there's that problem solved. Let's go on to the next. I only needed two rows. Let's go to the next one. Okay, now we're on to the second problem. 6n squared minus 23n plus 7. Well, the first thing we should notice on this problem is we have a positive c term and a negative b term. How do we get a negative b term? We have to have 2 negatives, because to get positive, you have to have a negative times a negative or a positive times a positive. So in order to get these 7s, the factors of 7 are going to have to be negative terms. So let's start off. I told you what my rules are. I like to lay out a pattern so that it always makes sense to me. And then I go over here and I start filling it in. I always use the lowest, the smallest factor of the pair first. That's only my preference. It's nothing mandatory. So I do a 1 and a 6. And then I repeat it with a 1 and a 6 because 6 and 1 are the factors of 6. And I have a 2 and a 3 and a 2 and a 3. These are all times, by the way. Done. Go here to the 7. All I have is a 7 and a 1. But guess what? They have to be negative. So it's going to be negative 1 and negative 7, and negative 7 and negative 1. Oh, I have 2 rows, 2 factors over here. Do it again. Negative 1 and negative 7 and negative 7 and negative 1. That's complete. Now we fill in the inner parentheses, starting with the FOIL terms, the F terms, going over here on the left side. We start with this 1 and the 6, and like I said, I put the first one way over on the left and the second one way over on the right. Do the same thing, way on the left, way on the right. Now I do the 2 and 3. The 2 is way on the left. The 3 is way on the right. 2 on the left, 3 on the right. Now we're going to do the L terms. Keeping them in order. Minus 1, minus 1, minus, oops, I missed it. Minus 7. Let me erase that. I got that dot in the wrong spot there. Oh, there. I'm doing blue. Okay, minus 7. So now I come down here with the minus 7 and minus 1. And do it again. Minus 1, minus 7, and minus 7, and minus 1. So now we have to multiply and add, right? The sum of these factors here. 1 times negative 1 is negative 1. 7 times 6 is 42, negative 42. Negative 42 and negative 1 is negative 43. Should have put a little more space in here. In this term here, again, now it's negative 7 and negative 6. So it's negative 42. Oh no, positive 42. Positive 42. Because these are both negative. Negative 2 times negative 21. Negative 2, not times, plus negative 21 is negative 23. And negative 14, 2 times negative 7 is negative 14, plus negative 3 is negative 14 and 3, 17. Negative 17. So which one is ours? We are looking for a negative 23. It happens to be this one right here. So now we take these terms right here and we fill in our solution, starting with the outer, that's the O part. Outer is 2, and the 1 is minus 1 way here. And then it's negative 7, and 3. And this is n, and n. So 2n minus 7 times 3n minus 1. That's the solution to that problem. Let's go on and do another one. Okay, so now we're on our third and final problem. So now it's 2y squared minus 5y plus 2. The first problem, I think, was minus 2y plus 5y plus 2. But as you can see, we have a negative sign right here, so that means that both of our factors of 2 are going to have to be negative, not positive. But they have to be the same, because in order to get a negative here. Okay, so breaking it apart as I always do, the 1 first, 1 and a 2, and a 1 and a 2. That's the only factors of 2. And I get over here for the L term, we have a 2 again. So it's a negative though this time. Negative 1, negative 2. And then we're going to switch it. Negative 2, negative 1. And these are multiplied terms. Of course you know that. Okay, multiplied. So now we fill in. So with the 1 and the 2 is put the 1 here and the 2 way over on the right. Put the 1 way on the left and the 2 way on the right. Now we're going to start with a negative 1, negative 2. Negative 1, negative 2. And now we're going to switch it. It's going to be negative 2, negative 2, negative 1. Okay, now we multiply and add to find out which is the one we want. So negative 1 times negative 1 is negative 1. Negative 2 times 2 is negative 4. Negative 1 plus negative 4 is negative 5. And we already know that's our answer. But we'll do the other one anyways. 1 times negative 2 plus 1 times negative 2 is going to be negative 4. And we do know that this is our answer. So now that we know that, we're going to fill in our solution. So the solution says we take the outer and do the outer terms of our solution. And it's 1 and negative 1. So down here we have a 1, and way over here a negative 1. Okay? And then we have a negative 2 and a 2. So we have a negative 2 here and a 2 right there. These are now it just need to be add the y, so we can add the y term here and the y term here, and that's our solution. Let's figure it out. Y times 2y is 2y squared, 2y squared. Y times -1 is negative y. Negative 2 times 2 is negative 4y. And negative 2 times -1 is 2. And then these two add together. I'll carry it over here. You get 2y squared minus 5y plus 2. And that's what we were looking for. Okay, now we're on example 2. This is where c is negative. There's a little different handling here, but we'll try to figure it out here. So the problem is 7x squared minus 26x minus 8. So we have the c term is negative. And the only way the c term can be negative, we've talked about this before, is one of the factors has to be positive and one of them has to be negative. It's the only way that the c term can be negative. And since we're looking for a negative 26 here, that means that the positive number, whatever you're looking for, and for the b term, that is the term that needs to be the largest. So the largest term is going to be the negative term. This is going to be the largest term right here, the negative term. So let's see what. So now you can know that I have factors. You see them, the factors? Okay, well, I'll show you when we get there. So now let's take it and break it apart. So we have the 7. This is the way they drew it up in the table. Here's the 7. You don't need any more because there's only 2 factors for 7. On 8, we have 4 factors, 2 sets, because you have 8 and 1 and 4 and 2. Okay? So when they broke it down, they did that. They 7, 1. Over here, they did the negative 8 and negative 1. Remember I said the negative must be the largest. So that means the 8 is the largest. Okay? So now we're going to do 8 and 1, 1 and 8, and then 2 and negative 4, and negative 4 and 2. So we flip-flop them, right? Remember the flip-flopping. The factors on the left do not flip-flop. The factors on the right flip-flop. So you get a pair, and then you reverse them, and then you get the next pair, however many pairs there are, and you keep doing that until you run out of pairs. And once we've done that, we have these all figured out. We fill it in. We take the 1 and the 7, and we're going to put the 1, here's the 1, and here's the 7, way over here. Just like I always said I do it. The 1 and the 7 on the outsides. And then now on the inside, you got a negative 8 and a 1, and they followed my suit, I guess, kind of by placing it anyways. They have the negative 8 and the 1. Negative 8 is here. I'll change that to red. The negative 8 is right here, and the 1 is right there. And then we flip them. The 1 and the negative 8. And you do the same thing again. Now, except we're using a different factor. So now it's 2 and negative 4 and negative 4 and 2. Okay? And in terms of the f term, the square term, that never changed. Outside, 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 1 and 7 on the outside, 1 and 7, always on the outside. If there was another term come up now, those I would put them all on the outsides. Nothing would change. So now we look at them. Negative 8 plus 7 is what? Is negative 1. Are we looking for a negative 1? No, we're looking for a negative 26. How about 1 plus negative 56? That's way too big. Negative 55. How about 2 plus negative 28? That's going to be negative 26. Well, look at that. And the other one is minus 4 or negative 4 plus 14 is going to give you 10. And yes, you know, we want that one right there. So when we do that, we're going to break these terms apart as we've always done. So the 1 is going to go here. The 1 is going to go here. And the 2 is going to slip out and go way over here, right? And then as far as these, the inner terms, those are the outer terms. The inner terms is minus 4 slides down here. I'm going to change the color on it. The minus 4 comes down here and goes to the minus 4. And the 7 goes around here and goes to the 7. And there's the solution. We put in the x's, since it's x term, and we have the answer. So let's move on and try some problems ourselves. Okay, this is example 2. Check your understanding. So you're going to be able to go off, stop the video, and try this. And then the next slide is also one more problem. We'll try to work that out, that you can stop that also. But the interesting thing to remember here before you take off is we're in the section now where it says that the C term is negative. As you see here, it's a -3 and -3 over here on B. I don't know what it is in the next slide. Doesn't matter, but it's negative. And in order for the C term to be negative, remember, you have to have one of the terms has to be a negative and one has to be a positive. Because you have to multiply them together to get a negative term. Okay? And also, if the middle term is negative, the middle term, the negative sign right here means that the larger factor needs to be the negative factor, and the smaller one needs to be the positive factor. So let's work it out and see how it turns out. When you return, we'll take care of that. Okay, now that you're back, let's go ahead and give it a shot. So I'm going to write this down the way I do them all. I'm going to start off with a parenthesis here in the beginning. At the H, right? At the H. So I have a parenthesis here. And then I have another parenthesis. And a plus sign. And another parenthesis. And an equal sign. And then another parenthesis. And so how many of these rows am I going to have? Well, apparently, if you look at the coefficients of the A term and the C term, they're both prime numbers. So all we have is a 5 and a 1 and a 3 and a 1. So kind of makes it easy. So we're going to start off with the 1 like I always do, and the 5. And at the right-hand side, it's going to be a 1 and a 3. But now this is the negative term. So 1 has to be negative and 1 has to be positive. Which one is the negative one? Well, since the middle term is negative, the largest term has to be negative. Okay? So over here, we've got, these are multiplied together. And now we're going to figure out what the inside terms are. Oh, and there's 2 rows. Since there's 2 columns, we don't have to do the second one here, but we're going to do a paren and a paren and a plus, paren, and an equals, and another paren, okay? And in this case, I can carry out the terms on the C term because we flip them, right? So this is a 1 and a 3. So now it's going to be a -3 times 1. But the 1 and the 5 stay the same, so we don't have to flip them. So the 1 goes in the very beginning, and the 5 goes on the right-hand side. The 1 goes on the left-hand side. The 5 goes on the right-hand side. You've seen me do this? You understand what I'm talking about. So for this one, it's going to be the 1 and the -3. So we're going to say 1. It's a positive 1, okay? And over here, we're going to have a -3. And then we're going to have the -3, and we're going to have the positive 1. So now we get to factor them. We get to find these equal signs. So this is 1 times 1, 1 times -3, -3 times 5, and 1 times 5. Well, 1 times 1 is 1. -3 times 5 is -15. Drew that backwards, -15. And this one here is 1 times -3, which is -3. And 1 times 5 is 5. And we're adding these, right? And what we're looking for is 14, a -14. So if we're doing this right, we're going to have a -14. We're going to have 15, -15 right here, and a positive 1 is going to be -14, -14. I didn't leave enough room here. Let me erase it. I just want to make sure we see that. This is going to be gone here. I'm going to get rid of that one right there. And I'm going to go back to blue. And I'm going to say parenthesis right over here. And this is a 1. Okay? So now this is right here. I'll have to go back to the eraser. Maybe I can make this work now. Come on, eraser. Yes, there we go. Okay, so back to the blue. And now this is negative 14. And this one is going to be negative 3 plus 5 is 2. Well, 2 doesn't do it for us. It's the negative 14 we're looking for. So that means this row here is our answer. And when we do that, our inner terms, this is the O and the I, okay? The outer and the inner, okay, and the last. Okay, so let's go ahead and let's take a look at this. So since this is it, I'm going to put down the parenthesis down here at the bottom. And I'm going to take the 1 here goes to the beginning. O for outer, negative 1. Negative 1 all the way over here on the right. Now I have the negative 3 goes here in this one. And the 5 goes up here at the front here. And these are D's. So D and D. And if we ran this out, you'd find out that this indeed, D times 5D is 5D squared. And if you add the D, 1D and negative 15D's, you're going to get a negative 14D. And a negative 3 times a negative 1. Oh, no, not, is that negative 3? No, it's not negative 3. Oh, it is negative 3 and 5. Oh, this is 1 times 1. This is not a negative 1. This is a positive right here. Right here is a positive 1. Right here. So when I bring this one down, this one is a positive 1 right here. So we're going to get negative 15 and plus 1, and then 3 times 1. Negative 3 times 1 is negative 3. And now it'll work out. So it's 5D squared minus 14D minus 3. Okay, now we'll do this one. I'm sorry that got a little screwed up, and my writing has caused a little hiccup in this, but hopefully I straightened it out for you. Let's do this one. We're going to do, we see it's negative and a positive, so that means that in order to get negative, you have to have a plus and a negative term for the 3, but you have to, your positive term is the largest term. So I'm going to do just what we did before. I'm going to do a paren, and I'm going to do another paren, plus another paren, equals, and get way over here so I can see what I'm doing, paren. And this one, these are both prime numbers, so there's only going to be 2. So I'll do this one again, plus this one, equals, give some space. Okay, so 2 and 1. I start with the 1. 1, 2. All positive. 3 is a 1. And I said that the larger term is going to be positive this time because this is positive. So now I'm going to say negative 1 and 3. Because the bigger term has to be the positive term. And since I have that, I'm going to do, I get to write these out. I'm going to write this one again here. So this is now flipped. So it's 3 and negative 1. I just switch them. The 1 and the 2, the 1 goes here, the 2 goes way over here, the 1 goes in the front, the 2 goes way over here. Now we take and try to fill in the second term, right? And it's negative 1, and 3, and 3, and negative 1. And these are times. Right there, times and times. So now we have to find out what on the equals is going to give us 1n positive. So we have, on the inside here, we have a 4, 1 times 4, 1 times negative 1 is negative 1, and 3 times 2 is 6. That is not going to give us to us. So let's see what we get here. 1 times 3 is 3. Negative 1 times 2 is negative 2. And when we add those together, we're going to get a positive 1. This is our solution. Here's our answer right here. Take the parens and bring them down. The 1 goes in the front. The 3 goes way over here in the 3. The negative 1 goes right here. and the positive 2 goes in the front right there. These are n's, so it's 1n and 2n's. And if you look at it, 1n times 2n is 1n squared. 1n times 3 is 3n. Negative 1 times 2n is negative 2, so 3 minus, plus a negative 2 is 1n. And negative 1 times 3 is negative 3. Okay, I think that took care of that. Okay, example 2, check your understanding. We're going to do the same thing. We'll pause and you can go off and try them and then try it and come back. This is the last problem of the 3 for this example 2. So give it a shot and see what you can come up with. Okay, now that you're back, let's take a look at it. First of all, we can see there's a lot of factors. 9 is going to have 9 and 1 and 3 and 3, and 20 is going to have a 1 and 20, a 2 and 10, and a 4 and a 5. So let's see if we can minimize some of this work we're going to do by maybe guessing a little more correctly. But to start off, we're going to go ahead and do the typical thing I always do. I'm going to pick out the F part, the O plus the I equals, and then way down here, the L. And for the L, I have a minus 9, and for the I have a 20p squared. Okay, and then we have these two here, which is minus 31 is what we're looking for. Okay, so we can do the 20s. Let's start with, I say let's start with the 4 and the 5, because that's probably closer to the 30 we're looking for. 20 and 1 isn't, I don't know how we get that necessarily, but let's just go with the 4 and the 5. So I'm going to say 4 and the 5. And depending on how many factors we need, we'll keep bringing it down. So there might be, we don't have to worry, we don't have to bring these down, but you know what I mean when I say we'll reuse the 4 and the 5. So in this case, we're going to say the 4 is going to go here, and the 5 is going to go here. We have another one, plus, and a 4, and a 5 on the outside. And then we're going to have another set of factors. I know we're going to do it, because we're going to have a 4 and a 5, and another set of factors, a 4 and a 5. And they're all going to be equal to something when we get done. For the 9, we're going to have a, and since it's a negative number, we're going to have a positive and a negative term, and I'm going to use the larger factor as the negative, because the term we're looking for is negative. So I'm going to say 1 and negative 9. Then I'm going to say negative 9, flipping it, and 1. And then what's the other term? We can have a negative 3 and a 3, and then a positive 3 and a negative 3. Let's go with these. If these don't work, we'll erase it and start over again, or maybe I can squeeze it in down here. So now we're going to take the 1 and put the 1 here, and the negative 9 right here. We know how to do that. And the negative 9 right there, and the 1, and the negative 3, and the 3, and the 3, and the negative 3. Okay, let's add them up, see what we got. We've got a 4, these are all times, right? Times, 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 times. So 4 times 1 is 4, 9 times 5 is 45, negative 45. Well, that's going to give us negative 41. That doesn't help us. We're looking for 31. Negative 9 times 4 is 30, negative 36, plus 5. 5 times 1 is 5. Negative 36 plus 5 is negative 31. We need to go no further because we found the negative 31 right here. If we had gone farther, it would be 4, negative 12, and 15, right? So it's going to be a positive 3. And 12 and negative 15 is going to be negative 3. So the 31 is what we're looking for. Here's our factor. We don't have to go any further than that. And I can draw our parens right here. Okay. And we're going to use this term right up here. So I have the 4 and the negative 9. And you know how it goes. The 4 here, the negative 9 on the far right, and the 1 right here, and are we in the right line? And the 5 right here. And I put the value in for P. It's P, 4P and 5P. And this is negative, and therefore this is positive 1. 4 times 5 is 20, p squared. 4 times negative 9 is 36, plus 5 is 31. There's our negative 31. And negative 9 times 1 is negative 9. There's our answer. Okay, I think that worked out pretty good for us. Example 3, factoring out a monomial first. Some monomials can be factored repeatedly. Continue the process of factoring until there are no common factors other than that of 1. A trinomial has a common monomial factor. To factor it before, if it has a factor it before trying to find the binomial factors. Okay, so let's take this one here. Let's just factor 20x squared plus 80x plus 35 completely, it says. So what we're going to do here is we look at this and we say, well, we can factor out of this 20, 85, and 35 a 5. Because we can take 4 5s out of 20. We can take 16 5s out of 80. And we can take 7 5s out of 35. So now what we're left with is the common factor 5 and the trinomial 4x squared plus 16x plus 7. And if we break that apart into the standard form where we've got the f term, the 4x squared over here on the left, and the middle terms, the o and the I terms kind of floating around in the middle. And then we have on the right-hand side, we have the L terms, the last terms, over here on the right. So we have the first and the last, and in the middle we're going to deal with the FOIL terms, the O and the I. So what do we get here? If we take the factors of 4, there's 2 sets. There's 4 and 1, and there's 2 and 2. Now there's something interesting about the even pair of like 2 and 2, and we could talk a little bit about that when we get done toward the end of this. However, so we can factor that 4 and 1 and 2 and 2, and on the 7, the C side, or the L, the C term, we have a 7 and a 1, or 1 and a 7, and that's it. It's a prime number, so there's only one set of factors. So how do we do this? So we take the 1 and the 4 on the left, and we leave a space for it right here. Here's that space that we leave, and we get an extra row. And we've talked about this before. So we put down the 1 and the 4, and we don't need to put a 1 and 4 again because we know it's the same. And then you fill in the C factors for the 7. And it's a 1 and a 7, and we reverse them, 7 and 1. We don't have to reverse the first term. Then we get down to the 2's, and I put down 2 rows and put on again 1 and 7 and 7 and 1. And I'm putting down 2 to show you that, look, they have the same number right here. That's because everything's positive. If these were different over here or negatives, you'd certainly have a problem. But even if you have a positives here and even if these are different and these are common, if it was 2 and 2 here, if one of these was negative, you'd certainly have to do both rows. But right now we're going to find out in this case, but it always pays to do both rows. We're going to find out that it's the same answer. So when we do that, we're going to find out that to get the 16x right here, 1 plus 28 is not going to get it to it. That's going to give us a 29. A 7 plus 4 is 11. That's not going to give us the 16. How about here? And you can see it's already true. So 2 plus 7, 2 plus 14 is 16. And then we can do the last one. 14 plus 2 is 16. So we're going to use this one here, this particular row, and we bring them down. So we're going to bring down the 2 here, and the 1's going to go way over here. And then we're going to bring down this 7 here, and the 2 is going to go right here next to it on the 2 inners. And now we've completed what we need to do, except for rewriting it and replacing and putting back in the 5 we removed up here. So now we go back to saying 20x squared plus 80x plus 35 is equal to 5 times the quantity 2x squared plus 7, 2x 2x plus 7 and 2x plus 1. Okay? Okay, chapter 3, check your understanding. You can go ahead and stop the video and try these on your own. And when you get back, we'll do them together. And then there's one more slide after this with one more problem. And you can stop the slide. I'll give you time to stop the slide there and do that one. And then when you come back, we'll work that one together. But this one is in the section or the area of this section of the chapter where they're talking about factoring out a common factor. So you know we're going to factor out a common factor. And keep in mind, don't forget your pluses and minuses, okay? So go ahead and pause. And when you come back, we'll start up. Okay, I've given you some time to pause and finish these two and come on back. So looking at problem A, we see that really the only factor that we have to worry about here is the 2, because the 2 on the 2v squared will factor out of all of the terms. In doing so, I'm going to put the 2 right here. I'm going to put the 2 right here, and I'm going to put times, and it's going to be what? It's going to be a v, right? And we're going to factor it. So, well, first I'm going to write the problem again. So it's going to be v squared minus 6v and plus 5. There's our new term that we're going to be working on here, okay? So now we're going to take this and we're going to put the parentheses down like I've been doing in the past. A parenthesis here, a little bit of a space and a paren and a plus and another paren and equals, and move over a little bit, put this in here. I'm going to put the 5 above us here. It's a plus 5. And I'm going to put over here with the V, I'm going to put the a 1, because that's our factors. Just a 1 is all we get. So before we get started, though, this is a positive C term and a negative B term. And that means the only way to get a negative B term is, if you recall, is we either have to have the same sign on the factors, right, of the C term. So 5 can be a plus 1 and a plus 5, or a negative 1 and a negative 5. And if we want a negative value in the center, it has to be the negative terms, right? So I'm going to write down the factors of our 1, and it's 1 and 1. And over here on the 5, we've decided that it's going to be the negative terms, right? So it's going to be negative 1 times negative 5. That gives us a positive 5, and it's going to give us a negative 6. I can see it coming, right? Because we have 1s here. This has to be the answer. So we put the 1 out here, and the 1 on the far left, and a 1 on the far right. And then we distribute. I know I have to rotate these. Okay, we're going to go like this and do it again. Although we probably won't have to rotate them, I'm going to do it anyways. Times negative 1, because these two 1s are the same sign and everything. And so we're going to bring down the negative 1 here, negative 1, and the negative 5. And I'll just, for the sake of being consistent, I'll do this again. I'll bring down this set of terms, plus, equals, and I'm going to put the 1 and the 1 where they belong. And now I got the negative 5 first, negative 5 and the 1. These are times. So now we have to add them up. Is negative 1 plus negative 5 a negative 6? Yes, it is. But guess what? Negative 5 plus negative 1. Oh, where did I get the other? I lost the negative right there. Negative 5 plus a negative 1 is also a negative 6. So because these are the same, there's no difference really. So, okay. So now that we have that, either one of these would work. So I'm going to now write the factors. So we got this, 2 factors of v squared minus 6v plus 5. And they are what? Let's use the one that we discovered first. 1 and minus 1. So we have a 1 going to go here, and the negative 1 is going to go way over here. And we have a negative 5 in the inner terms, and a 1. Okay? So that's it. Except for rewriting the original trinomial. So it's going to have the 2 in it this time. So it's going to be 2v squared. You must do this to prove that you've got the same answer, that you got the answer correct, plus 10 is equal to 2 times v, it's a 1v, but v minus 5 times v again minus 1. And there's our solution. So let's go ahead now and do, I should have moved that over a little bit, shouldn't I? So be careful on the next one, Bob. Can we factor out of the 4y squared plus 14y plus 6? Well, the only thing that's common to all of them, again, is a 2. I don't see how you can take anything more than a 2 out. So I'll write it with the 2 here. And it's going to be 2 times 2y squared plus, I took a 2 out. It's going to be a 7y, 7. And on the 6 here, it's going to be a plus. I took a 2 out, so it's going to be a 3. So this is the trinomial we're going to factor. So doing that, I'm going to put down the 2. And way over here on this side, I'm going to put the 3. And this is where we're going to have the factors, right? And then the 2 inner terms, plus here, and an equals. And then we're going to have parens way over here. Look familiar? These are prime numbers, 2 and 3, so there's only going to be one set of rows. So I can draw the other set of rows right now. And then I'll bring this one down because this is going to be, again, these are both positive. So since they're both positive, we can deal with the positive terms. So I have a 1 and a 3, and a 3 and a 1. Over here, I have a 2, so I have a 1 and a 2. And as you know, I always put the lower number first. So now that I've done that, I can take the 1 and I can put the 1 on the outside left and the 1 on the far right side there. And I can do the same thing. Oh, I'm sorry, the 2. The 2 on the far right side. And then I can put the 1 over here and the 2 on the far right side. Sorry about that, 2. I'm going to erase it, make it a little nicer looking. Okay. Put a 2 in there. Okay, there's the 2. So now I have a 1 and a 3 and a 3 and a 1. So I'll put the first one, I'll do the 1 and the 3. So the 1 goes here and the 3 there on the inside. And the 3 goes here and the 1 goes there. In fact, our terms are all laid out for us now. So given that, we have to add them. So we have 1 times 1. 1 times 1 plus 3 times 2 is 7, right? So that's going to be a plus 7. And we're looking for a plus 7. So so far, that's our answer. I wonder what the next one says. 3 times 1 is a 3, plus 1 times 2 is a 2. This comes out to be a 5. So you see this has to be our row right here. So given that's our row, I'm going to do this. Write down our parentheses for our factors. And we're going to bring it down. We're going to put a 1 here, and the 1 way out here, and the 3 here, and the 2 right here. We're going to add in the y's. So it's going to be 1y plus 3, and it's going to be 2y plus 1. And now to complete the problem, we're going to rewrite 4y squared plus 14y plus 6 is equal to 2 times y plus 3 times 2y plus 1. Okay, so now I'm going to move on to the next slide. Okay, now we're coming back on example 3. Check your understanding the third problem. I'll wait for you. Why don't you go ahead and stop the video and try this yourself. Remember your signs. Look at your signs. Look at your factors. Can you factor anything out? Okay, you know you can. Go for it. And when you come back, we'll continue on. Okay, now you've had time. You've finished. You're back. You finished your work and you're back. So let's give it a shot. So problem C. Can we factor anything out? The answer is pretty obvious that 18, 12, and a 6 all have a 6 in common. So I'm going to say yes. I'm going to factor out a 6. And how is that going to look? It's going to be 6 comes out of 18 3 times, 3k squared times, minus 6 comes out of 12 2 times k, and minus 6 comes out of negative 6 negative 1 time. So there's our new trinomial. And based on that, I'm going to put down a parenthesis here, a paren, and a paren, and a paren, and a plus, and a paren, and a close paren, and an equals, give some space, and another paren. So I'm going to put the 3 up above here, and negative 1 here. And I'm going to factor this. So these are primes, so there's only going to be one set of factors, so there's only going to be 2 rows. So on this side, it's going to be the 1 and the 3. And over here, I'm going to do the 1 and the negative 1. Okay, these are all times right here. Okay, so now the 1 and I do another set of parentheses too while we're at it. Parenthesis plus, parenthesis equals, and then I'll do this parens out here. And I'll just switch these right there. Okay, I switched 1 and negative 1, negative 1 and 1. So now on this side, I have the 1 and 3. So as usual, I'll put the first one here and the second one at the end. Put the 1 way at the beginning and the 3 way at the right side. And then I've got these. I'm going to put the 1 right here and the negative 1 right here. Okay. And on this one here, I'm going to put the negative 1 right here on the left and the 1 right here on the right. Now from here, we can do our adding. So these are times, 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 and times. So 1 times negative 3 is negative 3, and 1 plus negative 3 is negative 2. That is what we're looking for, is a negative 2, by the way. And now here we have a negative 1. 1 times negative 1 is negative 1, plus 3 is going to be a 2. Well, we're looking for a negative 2, and here it is. So it's this row. So we can do our factoring, create our factors, our binomial factors, by using this row. So from this column, the O, this is the O column, and the I, right? This was the L way over here, and this is the F over here. So the O means outer. So we're going to take these two and put them in the outer positions. 1 and a 1 in the outer positions. These two, a negative 1 and 3, negative 1 and 3 are the inner positions. We're going to add our K. So it's a K and a K. Okay. So now we've got the negative and positive already. This becomes a positive, and this is your negative. We already know that. So there it is. There's our factored trinomial, but we're not done yet. The reason why is we have to go back to the original equation, original trinomial, and get the 6. We have the 6. So we're going to do 18 k squared minus 12k minus 6, okay, is equal to 6 times k minus 1 times k, 3k rather, plus 1. Now that's our solution.